Hello, today we are looking at some more data information. We're going to explore outliers. Please set up your book so that you've drawn a line down the centre with a red pen and a ruler. You've put your title in and underlined it. You've put today's date and we will put in our Walt first. We will then have some examples and some exercises. So do that first, turn it off. Our outliers. So we're going to be doing, our Walt will be to explore the effect of outliers on summary statistics. Our summary statistics, our mean, our median, our mode and our range. So pause and copy that in as your Walt, please. Now for some examples. We need to understand what the mean and median and mode are first. So please copy down this so that you've got this information in colour or a cloud around it. So, centre, we're looking at the middle. Mean, that's what most people say is the average. You will often hear it referred to as the average, particularly in the media, but they're usually talking about the mean. Median, the middle, just like your median strip. Mode is the most common one that you see. We also look at the measure of spread called the range. So the range is the difference from the largest to the smallest. You find your largest and smallest and you subtract them. Let's have a practice of that. Sometimes you'll be given an exercise where you need to find the missing one. Okay, you'll be told which ones they are and what the answer is. So what I've done is I've added up the ones I was given, that is our formula, and divided by the number 1, 2, 3, 4, 5, and I found that there were 22, and 22 plus something divided by 5 had to be, the answer had to be 6. So 5 times 6 is 30, so I needed to add 8 to the 22 to make the 30. This one is in order already, so we are right there. And we needed to find the middle one, so I crossed out the 2 and the 4 and the 10 and the 9, and I've noticed that there was 5 and something. Remember, when there's an even number, there are 2 in the middle, you need to add them together and divide by 2, and the answer had to be 7. So 5 plus 9 is 14, 14 divided by 2 is 7. And the most common one, there's one of everything, we have to have a 5, so that had to be a 5. If you did not understand that quick one, let's go through it properly. Copy this down. This is what you would be thinking as you are doing it. So to find the missing one for the mean, you've got the sum of them all, so you would put them down. We don't know what that is yet. The number that we've got, there are 5 pieces of data, 1, 2, 3, 4, 5, and the mean is 6. So we're now left with 22 plus we don't know yet, divided by the 5 to equal the 6. What we do is we multiply both sides by 5. So if you multiply 5 divided by 5, you would get 1, and that doesn't affect the sum, and 5 times 6 is 30. 22 plus something equals 30, so we subtract 22 from both sides and we're left with the 8. Okay, now copy this down because this is what we are looking at today. You need to know the definition of an outlier. It is a data value that appears to stand out. So it's unusually high or low, it usually just stands out, and if you graph this, you will see it very, very clearly. So first of all, we're going to consider these values, 5, 6, 5, 7, 3, 9, 31, 8 and 7. So the 31 looked out of place, didn't it? The mean, you need to add all of these numbers up. You need to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you do that, you will find that the answer is 9. So add all of those up, comes to 81, and you divide it by 9, the answer is 9. We had to sort this, so you've got a 3, There are 2 5s, so make sure you put both the 5s in. There's a 6, 2 7s, an 8, a 9 and a 31. So the middle value, I've come backwards, 1, 2, 3, 4, and the one in the middle is the 7. Okay, then we had to remove the 31, so cross the 31 out, we don't need him anymore, and we're going to work out the mean again. We're going to add up all that data, but this time we're dividing by 8. So if you add up all of these numbers, but not the 31, and then you divide by 8, because we only have 8 pieces of data now, you'll find the answer is 6.25. Then it asks for the new median. So I've got this in the light blue. So I came back 1, 2, 3, but we've got that double data issue again, haven't we? So we need to add the 6 and the 7, and we need to divide by 2. So the answer will then be 6.5. I've actually done it over here accidentally for you. Okay. Now go through that a few times, because now I'm going to get you to work on one by yourself. So all the data went down, didn't it? So the median went down from 9 down to 6.5, so the mean, and the median went from 7 to 6.5. So 9 to 6.25 and 7 to 6.5. It got lower, didn't it? Here's a new set of data for you to have a go at. So here's all your data here. First one is to arrange it. So make sure you arrange it all in order, because you need to be able to do that. So you're arranging first from the lowest to the highest. Then I want you to calculate. So get your calculator out and calculate. Remember, range is highest minus lowest. Then I want you to identify. So when you've got them in order, you'll quickly be able to see any that are way too high or way too low. There could be more than one outlier. This time we're telling you there are 2. I want you to remove both of them and then do the data again. Okay, now pause, and I want you to do this on your own and see how you go. Okay. Putting them in order. Now when you mark this, please do not put crosses on your work. That doesn't help you when you go back to revise. Of course, give yourself a beautiful tick if you've got it correct. If you haven't, I want you to still use your red pen, but I want you writing the correct answer there. So when you revise it, you can go back and see the red pen and go, I got it wrong and that's the right answer. Can I now get that right answer? If not, I suggest you have a look through your videos again or ask your teacher. So you've put it in order. Now when you put it in order, I'm pretty sure you picked the outliers pretty quickly. But first we had to do the mean. Remember, you always write the formula first. Then you substitute all the information you know, and then you calculate the answer. Range, this is the formula. You put in, substituted your highest and your smallest, and you calculated your range. Now you identified those ones. I think that one was pretty easy. The 2 and the 43 really stand out, don't they? Now let's recalculate. So again with the formula, this time we are not including the 2 or the 43. We now don't have 12 items, we only have 10 items. You'll notice that the mean has changed, hasn't it? Range again, formula first. Substitute, we have a different higher number and a different lower number. You will notice that the range is significantly different, isn't it? Okay, make sure you've got all of that right first before we move on. Now you're asked to comment. Quite often in assessment it asks you to comment. So we're commenting on that effect. So you need to go back to these answers and have a look at the differences. So we're going to comment on the mean, and we're going to comment on the range. So we're going to use this information in our comment. Okay, the comment would be something like this. So these are the ones we used. We used mean and we used range. And we looked at the effect that these inclusions of outliers had. So the range has been affected more because the minimum and maximum values changed a lot, didn't they? That was the most significant one. The mean didn't change much because we took away a really high and a really low, and it seemed to balance out a bit, didn't it? So would the outliers have any effect on the median? Yes or no? Let's have a look. So whether we have the 2 and the 43 in, remove them, and they stay the same, don't they? So no, it won't, because we removed one from each end. So why do you have to be careful? It's going to change it, isn't it? The mean and the median are both affected by the inclusion of outliers. It makes it less reliable, doesn't it? These are statistics you might find because businesses use statistics to help them. And they've gone to a theatre and they've recorded the ages of the people. You might notice something as you go through those ages. Now, this was the statement that was made. The average age of people watching this movie in the cinema was well over 15. They've done the statistics. Average, so it's probably the mean. Therefore, teenagers would not enjoy this movie. Have a think. Yes? No? Yeah, I'm a bit dubious about that information. I'm going to go no with that one. You might go yes, that's up to you, but we have to justify. Now, this is an important thing in your assessment, is justify. So to justify, you have to prove it. So you need to make calculations with and without the outliers, which is exactly what we've been doing. So you need to make those, and then you need to write a justification. Okay, so here's your data. Do some calculations and prove whether or not that statement that the average age is over 15, therefore it's not a movie for teenagers, and prove it for me. Write your justification. So they worked out the mean, and they worked out the mean was 23.9 or nearly 24 years of age with the outliers, and the mean is 15. So remember the statement right back at the beginning, it said is well over 15. So 15 was that number they were looking at, and it proves that here that 15 was the average when you get rid of the 2 grandparents that turned up with their grandchildren. Okay, so this is a justification. These are the words that you need to use, not in the same order, sentences may be different, but you need to say that the mean age watching the movie was that and that, depending on your outliers. So we have a range of 55. When you remove the outliers, the range goes down to 5. So that's another calculation you may have done. And the mean became 15, and the median remained at 15. So when you do all the calculations, you can say it's fairer to say the average age at the cinema was approximately 15, but we're not going to look at the outliers. Okay, add anything there that you need to in red pen to your work. Pause it, and we're going to have another one. Students at a school. go through all of this. Remember, we're going to arrange it in numerical order, calculate the mean, median and mode. Pause and have a go. So you've put it in order. Every single piece of data is there. You've worked out your mean, you added them all up. That dot just tells you it's all the bits that are missing because they wouldn't fit. And when you divide it by, there were 20 pieces of information. That's what you got for the mean age. The median, you went into the middle and it was here, so it's 12. And the mode is 12. There are more 12-year-olds if you count them. Have a look, more 12-year-olds. How did you go? You getting that information? Well done. Very good. Let's have a look at the questions we're going to use now with that data. Make sure you've got the correct data written down so you can move on. Now we're going to change the data. We're going to add a 14-year-old. What could she say about her age in comparison? What would she say? So using all of these that we had before, they're all around 12, aren't they? So it's a little bit older, isn't she? Right? She is a little bit older. If we selected someone at random, most likely we're going to choose someone that's 12 or thereabouts, isn't it? Now we've got a university student attending. Is that going to affect our data? It is, isn't it? Because we're going to add an older person. We're going to have an outlier in there and they're going to change that median and the mode and the mean, aren't they? Now just have some fun. This time I'm not going to give you the answers because it's up to you. Oh dear, we're not focusing very well. There we go. Add any outliers. So go way down low, way up high, and just have a play with that and prove it to yourself that what I've been saying is correct. Thank you. Goodbye.